Hello everybody, today in ETS 551, we are going to learn about digital signal processing. So in this course outcome, upon completion, students will be able to determine solution of difference equations in discrete time system using impulse response and Z-transformation method. Analyze DFT and FFT to any discrete signals formation for frequency analysis observations. Discover appropriate digital filters that meet the desired requirements in solving digital signal system. Chapter 1. In Chapter 1, we are going to learn about the introduction to digital signal processing, which is the definition of signal and system and the classification of discrete time system. So what is signals? Signals are any physical quantities such as voltage, current, or velocity that varies with time or independent variables and carries information. I have given the example below. Signals may be classified into two categories depending on the characteristics of the time variable they can take, which is continuous time signal and discrete time signal. Continuous time signal is defined for every value of time. The signal varies continuously in time and amplitude, while discrete time signal defined only at discrete values of time. The signal take one finite number value at specific instant of time. The example I have given here. Next is basic discrete signal representation. Below here is the unit sample sequence, unit impulse. Next is the unit step signal. Next is the unit ramp signal. Lastly is the complex valued exponential signal. Next is systems. What is systems? System is a combination of a few components that are physically connected to perform a specific task, also defined as a physical device that perform operation on a signal, as shown in the diagram below. Systems may also be classified into two categories, which is continuous time system and discrete time system. Continuous time system is a system in which continuous time input signals are transformed into continuous time output signals. Meanwhile, discrete time system is a system that transforms discrete time input signals into discrete time output signals. A discrete time system is a device or algorithm that operates on a discrete time input signal or excitation, for example, X or N, according to some rule, for example, H of some discrete time input to produce discrete time output signal or response, for example, Y of N. The classification of discrete time system. Static versus dynamic. Time invariant versus time variant. Linear versus non-linear. Causal versus non-causal. Stable versus non-stable. Recursive versus non-recursive. Static versus dynamic. Static is a system said to be static if the present output depends only on the present value of the input, while dynamic is a system said to be dynamic with memory if present output depends on the past or the future input. Example 1. Justify whether the following system are with memory or without memory. Next is time invariant versus time variant. Time invariant is a system said to be time invariant if its input-output characteristics do not change with time, while time variant is a system said to be time variant if its input-output characteristics change with time. Example 2. Identify each of the following system, either time variant or time invariant. Next is linear versus non-linear. A linear system is one that satisfies the superposition principle. A nonlinear system is one does not satisfy the superposition principle. Superposition satisfies additivity properties, homogeneity properties where, if an excitation x1 of t causes a response y1 of t, and an excitation x2 of t causes a response y2 of n, then an excitation x of t, given by a times x1 of t plus b times x2 of t, will be represented as y of t in the solution, will cause the response y of t equals a times y1 of t plus b times y2 of t. Example 3. Justify whether the following system are linear or non-linear. This is the solution. Comparing a system against the properties of additivity and homogeneity determines whether it is a linear system. Moving on is causal versus non-causal. Causal is present output that does not depend on the future inputs, depends on past or the present input. Meanwhile, non-causal is present output that depends on future input. A system is causal if its present output depends only on past and present inputs, meaning it does not rely on future values. In the diagram, we assume the present value of the output is 5. If past values are less than 5 and future values are greater than 5, this suggests a dependency on future inputs, making the system non-causal. Example 4. Justify whether the following system are causal or non-causal. This is the solution. In number 1, since present output does not depend on future input, therefore, the system is causal. In number 2, since present output depends on future input, therefore, the system is non-causal. Next is stable versus non-stable. An arbitrary relaxed system is said to be bounded input, bounded output, BIBO, stable if and only if every bounded input produces the bounded, finite output. An unstable system usually exhibit erratic and extreme behavior and cause overflow in any practical implementation. Lastly is recursive versus non-recursive. A system is called a recursive system if its output yn at time n depends on one or more past output values, such as yn1, yn2, and so on. In contrast, if y at time n depends only on the present and past input, then such a system is called non-recursive. That's all for Chapter 1. Thank you.